Uh, so today we are going to talk about response spectrum. So this unit is about a spectrum. Today's first time is response spectrum. So why are we going to use response spectrum? Because this is mostly because in structure design we want to know the shear force V that happens to the structure due to the input earthquake AG. And most of the time we want to know the maximum value of this V. So what is V? It should be the inertial force due to the absolute acceleration of earthquake response. So if we divided m by V, so we can know that is the absolute acceleration here. Because m is decided by the structure themselves, so we are more caring about how strong the earthquake response Z absolute response will be. So as we want to know the maximum value, most time we take the absolute value whenever it's positive or negative, and take the maximum. Using a lot of different structure with different frequency, we can get their different seismic response absolute acceleration here, and link them together. We can get a frequency to response relationship. We call this relationship curve as a response spectrum. So here is a question. There's a structure A and structure B, and both of them have a mass and the K here. Structure 1 is with m equals 1, and the second one is m equals 10. And the first one's stiffness is K equals 10, the second stiffness is K equals 100. So what is the structural response is larger for these two structures? The result is they should be the same response. Let's see why this is going to happen. Firstly, we're going to look at the structure's equation of motion, just like the equations we already know. And if we divide m to both sides of the equation, we can get the equation change look like this. Here, the m is deleted. Here is c divided by m. Here's k divided by m. Here, this m is divided because 1. And as we know that omega 0, which is angular frequency of structure without damping, without considering damping, it should be k divided to m. Thus, k divided to m should be the power square, square power, 2 times power of omega 0. And for the damping, we know that is 2 times of critical damping root mk, and which we can change to multiple m here and get k divided to m like this. So by divide to m to both sides, we know that c divided by m is 2 times of h omega 0, where h here is the damping ratio. Finally, we can get our equation becomes this c divided by m becomes 2h omega 0, and k divided by m, it becomes omega 0 square. So we get this equation motion that is only about omega 0 and h. Of course, also input earthquake here. Thus, we can know that the structural response is only related to omega 0, h, and input earthquake. Whenever m to k changes, only the ratio of m to k is matter, because only omega 0 is matters. So we would more prefer to use only omega and h instead of mck to get the structural response. Here, how to do this is using again using the Newmark beta method, and we equals n plus 1 equals m hard divided by m hard. It becomes m divided by m equals 1, and other things becomes look like this. And we can get f hard is acceleration here without any m here, and v an here, and we can get an av look like this. Finally, we can calculate the absolute acceleration of n plus 1 step by response acceleration an plus 1 minus input ground motion agn plus 1. Thus, after calculating calculating the total response of the earthquake wave, we can get the maximum of the absolute value of this absolute acceleration results, and make them of the value of omega or t. So we can get a relationship of frequency or period with acceleration. This is acceleration, and you can make a program to calculate very easily.